Welcome to a demonstration of Engineering Base by Occotech. The Projects section in the database is where projects will be saved. Catalogs are available for supplying catalog data. The Stencils area is for all of the graphical representations. Sometimes the tree might be a little bit long for the task at hand, so we can reduce the amount of the database that we currently work in using the shortcuts in our navigation pane. We can add individual shortcuts too, for example, the EB cable truck example project here into our navigation pane by clicking on Add button. The shortcut will always bring us back to this project. It will be easily accessible from the navigation pane. A project can be broken down into separate sections as equipment, potentials or signals, and document level, where our Visio drawings can be stored or previewed with our preview function, which we are now just moving to the right and expanding, giving us an overview of what the sheet will look like without actually opening it in Visio. As we see, this particular project is broken down into various folders containing the different sections of the vehicle. We see some logic diagrams as well as circuit diagrams. When we continue, we find our wiring diagrams. There are no limits to how far you break down your document structure, how many levels you want to use for separating the documents, and additionally, there is no limit on number of sheets. Some projects might be very large, while others are slightly smaller. One way of opening the Visio diagram is to double-click on the icon. When we actually get into the drawing itself, we see various symbols of connectors, devices, cavities, and different information depending on the symbols we have chosen for the representation. No need to worry about saving either. Your drawing automatically saves once you exit Visio. So all graphical changes will be stored in the database. Continuing, we see some harness diagrams with a layout of the harnesses, showing insulation and breakouts. Back in the topology, we see the layout of our vehicle, showing device locations and harness paths. If we zoom in a little bit further, we can see more details on the car topology plan. We can navigate into the tree to find the objects behind the graphic. Here we see a slot of a component or the connectors of inline connection points. Harness tags show us detailed information about the harness, including the destinations, or where the harness is connected to. Navigating again to the object into the tree, particularly a connector here in the ABS harness, we can navigate to other spots in the project where this connector has been used or is graphically placed, so we can see different levels of details of each object simply by navigating from one spot to another or to the next level of details into the wiring diagram. Navigating will open Visio, highlighting the selected object where we can simply zoom to. Jumping to the next representation on the large harness diagram, if we zoom to where this particular connector is placed on the sheet, we can see an overview of the connector face itself, an online table showing the contents of the connected wires, as well as some more information about pins, cavities, and material selections. We can arrange the Visio sheets so we're able to see an overview of all the various representations. We'll open a device worksheet showing us the content of the harness, giving us an alphanumerical overview of the objects we find in the harness itself. As we see the connectors here, we can now look at the designations. We see the object itself in the tree, in the different sheets, and we see it again in the worksheet. As this is all connected to each other in the database, there's only one object. Although it has multiple representations, we can change a name in one spot, and as soon as we do that, the database will update all representations anywhere in the database. Let's open up a different type of worksheet this time, not to show connectors, but to show wires. We can again navigate to the object itself or a representation of the object in the Visio sheet. We are again changing the name, and now we see the change occurring everywhere. The same method of changing things will always apply to any object. Anywhere the wire is used, the name of it will always be updated, so changes will always be reflected everywhere. Any table showing the name of the wire will also always show the changed name. Let's move on to another feature, highlighting routed wires. We've highlighted the first wire here. If we do another one, we see different colors representing different paths through the harness itself. We can highlight individual wires or even cables containing a set of wires. Here, we can see overlaps where they share the same path, highlighted in turquoise. We can highlight here on the connector itself, which shows the path of all the cables and wires connected to this particular connector through the harness diagram itself. All these materials are part of the harness definition. We can have a view in our BOM, the worksheet showing us the contents of the harness. We see our support materials, connectors, tubes, and so on. Here we find the length information, which is calculated through our integrated add-ins when we route our wires through the cables. We can easily export these into Excel or other formats as needed. Shifting to our next diagram, have a quick look at our form board, which is created through our form board mechanism, part of the manufacturing framework. This diagram will have the original length of the segment itself for manufacturing purposes. The next interesting feature is the so-called data tracking. Using this, we can define tables of alphanumerical data to compare. We create snapshots and are able to compare them to the current project or from one to another. We're now comparing to the current project, and we will see the changes we've carried out earlier. We can now go back to the device, which has been changed, and take action in retracting or accepting the change, given the current situation. A pre-prepared wire list shows us our wire that has been modified. We can also see the change that we carried out on the connector, as the connector is one of the destinations. Now we navigate to the wire itself, and we can have a look at the history, which is another feature you can use within Engineering Base that track all kinds of changes. Here we see the particular old values, the new values, and we can see additionally who carried out the change, when, and take actions if we deem necessary. We can follow up some more of the changes by navigating to the connector, for example. We can now see its history and who caused the change. The upper text field can be used for comments if you would like to comment on the change. Oftentimes, the whole functionality of workflow is meant to result in documents which we can create and provide to our customers or other departments. We extract documents using the Smart PDF feature in Engineering Base. We can now save them to our file system for further distribution or whatever you need. As we started the export on the top project level, the export took along all documents it found. A Smart PDF indicates that the document has a little bit more than general printouts. The object resemblances are connected to each other, so you can walk through the document itself from one representation of an object to another. Back in EB, we can have a look at the hydraulic and pneumatic parts. In our diagram, we can navigate back to the objects from the sheet. We find parts of the valve here, as well as some of the electrical controls, connectors, and devices. Navigating back to the harness diagram, we see our connector face with online tables right beside it, showing you once again the capabilities of Engineering Base. To learn more, visit our website at bwswire.com or email us to get started today.